Hi everyone, with this video I'm going to walk through a sample data set on how to use Excel to create a graph for Avogadro's number experiment. My sample set will be zinc, your sample set is copper, so there's a few different things about my sample set here than there are yours. So the very first thing is obviously zinc weighs different than copper, so I have a different mass right here. I'm going to pretend though that my experiment, when I was running it, had the same average current, and the charge of an electron is constant anyways. And then as far as my data goes, I have inserted these numbers for my zinc experiment, and you will have different numbers for your copper experiment that are found in the sample data set. So you need to make sure that you move all of those numbers correctly over into the template here. Okay. So looking over the Canvas page, there are two main values you need to calculate, which are moles of electrons lost, and we're going to calculate that starting with the mass of the metal that was lost, dividing that number by the molecular weight, and then multiplying that by 2, because in the balanced chemical equation, for every 1 mole of metal we lose, we produce 2 moles of electrons. And the second value we need to calculate is the number of electrons lost, which is going to be from the current. How many electrons did the current kind of push into the metal? So that value is done with amps. So we have the coulombs per second. We multiply that by the time the experiment was running in seconds. And then we will divide that number by the charge of an electron to get the total number of electrons lost. So we need to calculate those numbers for each trial, given the values for the trial. And then in order to plot, we need to calculate the total moles of electrons lost and number of electrons lost after each trial. So for example, in trial 2, this value needs to be the moles of electrons lost and of trial 1 plus trial 2. Trial 3 needs to be the value of moles of electrons lost for the sum of those 3 trials. Okay? So let's walk through how to calculate this data. Okay? The very first, we'll start here and we'll think about the values per trial, and then we'll finish by doing the totals, and then I'll graph. So in order to calculate the moles of electrons lost, we need to know the mass of copper that was lost, sorry, the mass of zinc that was lost, because I'm using zinc. And we're given them, after each trial, we've weighed our copper or zinc electrode to see what mass was lost. So in Excel is like one massive big calculator, and Excel is great because if you link all of the cells together in your calculations, if you accidentally inserted a wrong value, you could change that, and then Excel automatically auto-corrects all of the values you have everywhere, even in your graphs. So when we do calculations in Excel, I highly encourage you to use the cells to do your calculations. And so here's what I mean by that. If we're trying to figure out what's the mass of zinc lost, or for you guys it'll be copper, how would you do that on a physical calculator, right? At the end of trial 1, what was the mass of the zinc that was lost? And in your calculator, you would take the initial mass, for me it's 38.315, and then subtract the mass at the end of trial 1, which would be 38.261. So in Excel, we can do that same calculation, but instead of typing in the numbers, we can just use the cells that we already have those values in. In order to do that, if you want to make a cell in Excel a numerical value from a calculation, you can hit equals. So I want this cell to equal 38.315 minus 38.262. Or in terms of Excel, I want this cell to equal cell C11, so C11, minus cell C12. Enter. You would see that if you did the same calculation on a calculator, you would get 0.053. Right? Now what I want to do is I want to repeat that, that calculation, right? If I wanted to calculate this next trial, I would take 38.262 and subtract 38.213. So you could do that physically by hand, but the other beauty of Excel is that it can quickly calculate similar calculations for you immediately. And how you do that is, notice that right now my cursor is a white plus sign. If you highlight the cell that you want to repeat the calculation for, if you go to the bottom right corner, you'll see the white plus sign turns to black. If you see the black plus sign, you can click and hold as you drag that down and then release. When you release, you should see that it automatically fills in those values. So what was going on there? So in my very first cell, I just wanted it to be this cell minus that cell. So the cell above minus the cell below. When I dragged it down to the next one, it kept that idea of subtracting a cell above and a cell below, but then it moved it down into the next cell. So it shifted the two cells that it was going to be subtracting. I always suggest that when you do those calculations, you click through and make sure that these values are exactly what you want them to be. If you've used Excel for 20 plus years, you probably don't need to do that step where you go through and check. But my guess is that a lot of you are new to Excel or fairly new. So I highly encourage you to just check by clicking on the cells and making sure they are exactly what you want them to be. Okay, so now to calculate moles of electrons lost, we needed to calculate the mass, right? So I want this cell to be equal to the mass that was lost of the metal from the trial, divided by the molecular weight of the metal. So again, I'm using zinc in my example. You guys will be using copper. But one thing about this is that these values up here are constant, meaning they never change. So I want to hold this cell constant because I want to click and drag again. But if I were to click and drag, every time I go down, it's going to change this red cell and move it down one as well. So I want to hold it constant. I always want all of these values to use this same cell. To do that, we employ a dollar sign. So you can put a dollar sign in front of the letter and in front of the number, and that will hold that cell constant for all calculations that you'll use. So remember, it was mass divided by molecular weight times 2. So I could say times 2, just multiply by 2. Remember, the 2 is for every 1 mole of metal, I'm going to form 2 moles of electrons. And please review the Canvas page that walks through that calculation if that sounds confusing to you. I'll hit enter, and that's how many moles of electrons were lost. So now again, thanks to Excel, I can just click the cell I just created, move my cursor to the bottom right to see the black plus sign, click, hold, and drag down, and release. And that quickly calculates that value. Again though, since we're new, you should click through and make sure it's what you want. So trial 2 needs to be the mass lost from trial 2 divided by the molecular weight. See, it held that cell constant, times by 2, perfect. That's that one, that's that one, and that's that one. The nice thing about Excel is it color codes all of your boxes as well, so it makes it easy for you to review and see where cells are at. Okay, now for electrons lost. The number of electrons lost, we calculate from the current, right? We're gonna take the current, how much charge was running through in coulombs per second, so that's 0.5. So I want this cell to equal $C $6. I can type it or I can click it and edit it. You can do this a lot of ways in Excel. So I want it to be the current, and I have to hold that constant for all my calculations, right? Times the time, experimental time, how long was that current on for, and then divided by the charge of 1 electron, which is 1.6, well, it's this cell right here. So I'll click on the cell and then I gotta go back in, and remember, because I want to hold that cell constant, I need to add dollar signs. So just to review, this cell is going to equal to the current multiplied by the time of the experiment in seconds divided by the charge of an electron. And it should be a fairly high number, like e to the 20th. That makes sense. So click, and then I want to massively reproduce that calculation, so click and drag to bring it all down. And like I said, just go through and double check that these cells are what you want. Sometimes if you're in Excel and you accidentally click on another cell that has a number in it, it can change what is in your box. Just hit escape, calm down, hit escape, and it'll get you out of the box, just like that. I hit escape and I'm out of that box. So if I'm here, I can just hit escape and it'll bring me back out. Okay. So that's the amount of moles of electrons lost per trial, and this is the number of electrons that were lost per trial. Okay, so if I can plot moles versus number, or number of electrons on my y-axis and moles on my x-axis, moles of electrons, the slope of that line tells me what Avogadro's number is, because units of Avogadro are number over moles, right? It's the number of atoms per every 1 mole of atom. So my change in y, number, over my change in x, moles, is Avogadro's number. But before I can do that, I need to find what the total was after each trial. Okay, these are the values for the individual trials. Now I just need to sum those up. So for the moles of electrons lost, I will say that I want this cell to equal to this value right here, right? For the next one, I want this one to equal the sum, so I can type the word sum, of these two right here. This one, I want it to equal the sum of these 3 values right here. So I just came over here, I clicked on the third trial, and I kept holding down, and I moved my mouse up from trials up to trial 1. So that'll be the sum of all of those trials. I want this cell to equal the sum of, click on trial 4, highlight up past 3, 2, and 1, release, enter. And I want this one to equal sum, click all 5 values, enter. That's one way you can do it. You can use the sum column. If you want to be sneaky and tricky and clever and be able to use that black plus sign drop down, here's how you can do that. So to figure out the total sum of electrons lost, so now I need to start summing up these columns, I want this cell to equal to this value here. Now this one I want to equal to the number of electrons from trial 2 plus this box over here, because this box is always going, the box above the current cell I'm at will always be the new running total of total electrons. So equals. Now I can just right click, highlight that cell, right click and drag down, and you'll see that that number is increasing every time. 1, 2, 3, 4, right? And that's e to the 20 and then e to the 21st. Just to double check, this cell is equal to the number of electrons lost from trial 3 plus the numbers from trials 1 and 2. This cell is equal to the number of electrons lost in trial 4 plus the sum of the electrons from 1, 2, and 3. And this cell is equal to the number of electrons lost from trial 5 plus the sum of the electrons lost up through 1 through 4. All right, so now I'm going to plot my totals. And in order to, whenever you're making a graph in Excel, you always need to have your X values first and then your Y values second. So I just am going to highlight those values that I want to plot, and then I'm going to go over here, okay, to insert, and I'm going to insert a table. So yeah, I apologize if your Excel looks slightly different, but essentially you want to insert, and somewhere I have these little icons. These are graphs, a bar graph, a pie graph. I want to insert one of these scatter plots, okay? XY scatter is what it's called. And there, even if you do the little click the drop down, they give you all these options. Do not do the ones that already have the lines on it. That's not what science is about. No. We just want this randomized, the random dot one. So I'm going to click on that, and it inserts the chart into my field. I'm just going to go ahead and kind of move this below so I can work in it a little bit. All right, so now it's time to dazzle up this chart. The first thing we should do is we should add a trend line. I like, though, the fact that I can see that this line looks fairly linear. I have my moles at the bottom, right? And I've got on my x-axis, and I have my number of electrons lost on my y-axis. To add a trend line, simply click on the data points and then right-click. On my Mac, since we don't have right-click button, you hit Control and you click on your on the tap pad. Move down to Add Trend Line. So notice it puts the trend line in and opened up this second box right here, okay? You can change the type of trend line you add, but I just want to keep it linear because it is a line. And then towards the bottom down here, I want to click on Display Equation on Chart and display my R-squared value. The R-squared value tells how well does the line agree with your data. A value of 1 exactly means that that is the best fit ever. But mine, look, my R-squared value is 0.999999. So this is a very straight line. It's okay to have a value of like 0.97 or 0.95, like that's still okay. If you have a value that's 0.2, that is not a good fit for the data. But anyways, I digress. I want to add more significant figures because remember, Avogadro's number is 6.022E23, and this says that my slope here, y equals mx plus b, my x is 6E23. But is that really 6, or is it 6.1, or is it 5.9? So let's add some more numbers here. So if I highlight and click on the box, I see that for me at least, I have these options that pop up over here, okay? And they're label options. And I can change the color, right? I can fill it with something. I can put a border around it. I can add a shadow. I can change the alignment. But if you click on this very last one, I can change the way that the number is displayed. Right now it says it's being displayed as general, but I want to use scientific with 2 decimal places. So notice that changed my 6E23 to 5.9323. So that looks great. I'm going to move this over here in this clear space, and also I'm going to change the font size. In order to do that, I click up here on home. I go back home to where I can change the, the font and the size, and I'll move it up to like 14. I mean, I don't know why Excel's default is 9. So small. All right. Now, before you finish your chart, we need to be able to add, actually, I'm just going to close out here. I need to add my X and Y axis labels, right? You need to put a proper title in on your chart, and then I need to add my X and Y labels. So to do that, I can, if I click out and I click back in, up here somewhere, I have chart design. I click on chart design, and I can add a chart element. And I can add axis titles, right? You can change the chart title, you can add data labels, error bars, legends. We don't need any of that. We just want to add the axis titles. I need to add a primary horizontal, and I have to go back and do it again to add a primary vertical. Then I can click in, right, and just type what I want. So this is moles of electrons lost. Make sure you have your units there. You could just say electrons lost, and over here I could say, actually we should say total, right? Total electrons, and that's just a number. And this is total electrons lost. Oops, and that's moles. Okay. I could change the font sizes of these, make sure that you also add a chart title, but that should get you, at least that should help you analyzing the data. I'm going to leave it up to you to determine what you want the title of your chart to be, how you want it to look. Do you want to increase the font sizes of these or not? Make it easy for me to read. I am fairly young, but 0.9 font is so tiny. Don't forget, you can also, if you click out of the chart and then click back on the white space in the chart, if you right click, you can save your chart, your final graph as a picture. That's one thing you can do. You probably should be able to also, if you click on it somewhere towards the top, what if I want to save file, save as? Let's see what this is doing. No, that's going to do that. I believe, yeah, you should all be able to right click on your chart and save it as a picture. So you can do that and then upload that onto LabFlow when it asks you to upload your graph from your data. Remember, you guys are using copper, I'm using zinc. My numbers are slightly different than yours, but if I were to calculate my percent error, I think it'd be pretty close.